Okay, hi. So this time I'm going to talk about the Aloha network. I'm doing a pen and paper version of the video because I think that's more, convenient for me to do and like show everything instead of my iPad. So here it goes. We have n network nodes and that have a common communication channel. And the time is divided into epochs. That's basically the time slots. And xk denotes the number of active nodes at the end of the epoch. End of the epoch is important. Epoch is again the time slot that we are talking about. And there are two things that happen. The first one is a collision. So there are n network nodes, right? And all of them have the same common communication channels. So it's like this is the central computer, and there are n nodes around it. All of them are trying to send at the same time, but then there are because if all of them use the same frequency, then it garbles out and doesn't make sense. So that is called a collision. So if two nodes transmit at the same time, right? So that's a collision. If any one of them sends, then it's not a collision, so it's fine. Now we say a node is active if it has a message to send, right? Now if a node is active near the end of an epoch, it tries to send with a probability p. So if a node is active near the end, if it has a message near the end, sends with probability p. So it sends with probability p. 1 minus p, it does not send, right? If a node is inactive at the beginning of an epoch, then at the middle of the epoch, it will generate a message to send with probability q. So if it is inactive at the beginning, then at the middle of the epoch, it generates a message with probability q, does not generate a message with probability 1 minus q, right? All right, so the first question is, we also assume that n is equal to 2, so there are just two nodes, and x0 is equal to 2. So there are two nodes that are active, so both nodes are active. Like this is a big one. This will help you solve all the questions you want, that both nodes are active, right? All right, so how do we know that px1 is 2? That's what we've already done. It's all solved in the textbook, right? So let's just do px1 is equal to 2. How does that happen? What does this mean, x1 equal to 2? That means two active nodes are there. We already had, so we know that x0 is 2, so there were two active nodes. How do we know that there will be two active nodes even at the end of the first time slot? Let me just draw a time slot here. I'm just going to put the values here, x values. This is 0, this is 1, this is 2. We know that this is 2 already. We want to see that if x1 is equal to 2, what can happen? Like what are the ways that we can have x1 as 2? So for x1 to be 2, either the existing nodes do not send, or they both send. And if they both send, they're going to collide, right? So the probability that they do not send would be multiplying both of them. So if there are two nodes, 1 and 2, what is the probability that one does not send? The probability that one does not send is right here. This is 1 minus p. The probability that 2 does not send is also 1 minus p. Now the probability that both send is p. So then we just have to multiply both of them because they both need to happen at the same time. That's 1 minus p square. And they both have to happen at the same time. So the probability that x1 is 2 is a addition summation of both of them. So it is 1 minus p whole square plus p square. So that's when x1 is equal to 2. Okay, that's only x1 is equal to 2. Now we look at what's the next thing that they talk of x2 is equal to 2. Okay, we'll look at that now. So again, we break it down. We don't know what happens with what x1 is equal to. So all the possibilities that are there, that x1 would be 0, that changes to x2 to be 2. That's the first case. Or the case is x1 is equal to 1 and it changes to x2 is equal to 2. Plus x1 is equal to 2 and that stays the same, right? So there are no active nodes and they convert to 2. There's one active node and that converts to 2. Or there is two active nodes that continue to be 2, right? But we know that x1 cannot be 0 for sure. Why? Because x0 was 0, x0 was 2. Now both of them cannot send at the same time, right? So x1 could be 1, but it cannot be 0 because during the first epoch, max one node can send the data. Okay, so this is 0. Plus, now we have x1 is equal to 1 and x2 is equal to 2. And x1 is equal to 2 and that stays the same, right? So now what we do is we find the value of p, given p of x1 is equal to 1. What happens with this? So what is the probability that x1 is equal to 1? That would be the case when only one node transmits. So if there are two nodes, 1 and 2, this transmits with a probability p, and this does not transmit is a probability 1 minus p. This transmits is 1 minus, does not is 1 minus p, and the second node transmits is p, right? So the probability that this happens in this epoch is p times 1 minus p plus p times 1 minus p, that is 2 times 1 minus p. So that is p of x1 is equal to 1. Again, how is p of x1 is equal to 1? Only when after the first epoch, during the first epoch, the first node sends, the second does not, or the first does not and the second does. That's how we get px1 as 1. Like similar to how we calculate px for x2 is equal to 2, right? Right here, where we said that both of them don't transmit, right here. If both of them don't transmit, or both of them do transmit and they collide. For px1 is equal to 1, we don't want any collisions and at least one of them transmits. So now we have p of x1. Now we want to find p of x2 is 2 given. So now we'll have to break it down again into smaller ones. So we know that if x1 is equal to 1, that means only one active node was there. And now we want, so this is given, right? This is given. So when I have p of ab, that can be read as p of a given b has occurred, right? Okay, so only one active node is there. That is what we want to find. we're given that there is only one active node after first epoch. Now we want to find x2 is equal to 2. What are the ways that can happen? So the first and foremost thing that has to happen is the first node that was active generates a message. If this does not happen, then there cannot be two nodes at all. So a new message has to be generated, and to generate a new message, the probability is Q. So that has to happen. Now, the second event that has to happen is that both of them either send the message and collide, or they don't send it at all. So that is similar to having px1 is equal to 2, right? So again, what did I do here? I wanted two active nodes, given that in the initial epoch I had one active node. So how does that happen? So for that, the one active node that was already there has to generate a message. So now I have two active nodes, right? Now two active nodes have to stay active. For that, they have to either send and both collide, or none send. It can never happen that only one of them sends, right? So the probability would again be that would be p square plus 1 minus p square. So that is q times p square plus 1 minus p square, right? So that is what the Aloha network states in the textbook. So that was the first thing we found, was the probability for two active nodes to be present after the first epoch, the probability of the network to have two active nodes in the second epoch, right? So this was p of x2 is equal to 2 given p of x1. So this was this part. x1 is equal to 1 given, x2 is equal to 2 given x1 is equal to 1, right? And then now we have to find that x1 is equal to 2 gives x2 is equal to 2. So the only way that is possible here is if both of them don't send, or okay, so we found this out, right? X2 is equal to 2 given x1 is equal to 1. Now we just need to talk about this, that p of x1 is equal to 2 would also have x2 is equal to 2. For that, it is the same thing. None of them send or both send. So that is p square plus 1 minus p the whole square, right? And so at the end of the day, p of x2 is equal to 2 given p of x2 is equal to 2 is 0 plus p square plus 1 minus p the whole square plus q times p square plus 1 minus p the whole square, and that's your answer.